Heoxyacetylene torch acid rain that is acidic because gases such as sulfur dioxide are dissolved in it, from burn. Everything is made of particles. Made of particles rock, air, and water look very different. But they have one big thing in common, they are all made of very tiny pieces, far too small to see. For the moment, we will call these pieces particles. In fact, everything around you is made of particles, and so are you. Particles on the move. In rock and other solids, the particles are not free to move around. But in liquids and gases, they move freely. As they move they collide with each other, and bounce off in all directions. So the path of one particle, in a liquid or gas, could look like this. From here to here. The particle moves in a random way, changing direction every time it hits another particle. We call this random motion. Some evidence for particles. There is evidence all around you that things are made of particles, and that they move around in liquids and gases. Look at these examples. Evidence outside the lab, all made of particles. One, cooking smells can spread out into the street. This is because smells are caused by gas particles mixing with, and moving through, the air. They dissolve in moisture in the lining of your nose. 6. 2. You often see dust and smoke dancing in the air, in bright sunlight. The dust and smoke are clusters of particles. They dance around because they are being bombarded by tiny particles in the air. State S of matter evidence in the lab: air particle. Water particle. Particles from the crystal mix among the water particles. Water particles. The crystal. 1. Place a crystal of potassium manganate, 7, in a beaker of water. The color spreads through the water. Why? First, particles leave the crystal, it dissolves. Then they mix among the water particles. Diffusion. In all those examples, particles mix by colliding with each other and bouncing off in all directions. This mixing process is called diffusion. The overall result is the flow of particles from where they are more concentrated to where they are less concentrated, until they are evenly spread out. So what are these particles? The very smallest particles, that we cannot break down further. Electroplating means using electricity to coat one metal with another, to make it look better, or to prevent corrosion. For example, steel car bumpers are coated with chromium. Steel cans are coated with tin to make tins for food. And cheap metal jewelry is often coated with silver. The drawing on the right shows how to electroplate a steel jug with silver. The jug is used as the cathode. The anode is made of silver. The S, to shift equilibrium towards the product. The graph on the right shows how the yield changes with temperature and pressure. A polymer? A polymer is any substance containing very large molecules, formed when lots of small molecules join together. For example, other polymers by addition. Look at the polymers in this. Other polymers by addition. Look at the polymers in this table. You have probably heard of them all. They are all made by addition polymerization. Biotechnology and genetic engineering. Use of bacteria in biotechnology and genetic engineering. Reasons why bacteria are useful in biotechnology and genetic engineering. Biotechnology. Role of anaerobic respiration in yeast in production of ethanol for biofuels and bread making. Investigate use of pectinase in fruit juice production. Investigate use of biological washing powders containing enzymes. Biotechnology and genetic engineering. Biotechnology is the application of biological organisms, systems, or processes to manufacturing and service industries. Genetic engineering involves the transfer of genes from one organism to, usually, an unrelated species. Both processes often make use of bacteria because of their ability to make complex molecules, proteins for example, and their rapid reproduction rate. Use of bacteria in biotechnology and genetic engineering. Bacteria are useful in biotechnology and genetic engineering because they can be grown and manipulated without raising ethical concerns. They have a genetic code that is the same as all other organisms, so genes from other animals or plants can be successfully transferred into bacterial DNA. Bacterial DNA is in the form of a circular strand and also small circular pieces called plasmids. Scientists have developed techniques to cut open these plasmids and insert sections of DNA from other organisms into them. When the bacterium divides, the DNA in the modified plasmid is copied, including the foreign DNA. This may contain a gene to make a particular protein such as insulin, which can be extracted and used as a medicine to treat diabetes. Investigate use of lactase to produce lactose-free milk. Production of antibiotics. Use of fermenters in penicillin production. Genetic engineering. Define any genetic engineering. Examples of genetic engineering. Outline genetic engineering. Advantages and disadvantages of genetically modifying crops. Biotechnology. Although biotechnology is hot news, we have been making use of it for hundreds of years. Winemaking, the brewing of beer, the baking of bread and the production of cheese all depend on fermentation processes brought about by yeasts, other fungi and bacteria, or enzymes from these organisms. Antibiotics, such as penicillin, are produced by mold fungi or bacteria. The production of industrial chemicals such as citric acid or lactic acid needs bacteria or fungi to bring about essential chemical changes. Sewage disposal, Chapter 21, depends on bacteria. In the filter beds to form the basis of the food chain that purify the effluent. Biotechnology is not concerned solely with the use of microorganisms. Cell cultures and enzymes also feature in modern developments. In this chapter, however, there is space to consider only a representative sample of biotechnological processes that use microorganisms. Biofuels. The term fermentation does not apply only to alcoholic fermentation but to a wide range of reactions, brought about by enzymes or microorganisms. In Chapter 12, the anaerobic respiration of glucose to alcohol or lactic acid was described as a form of fermentation. Microorganisms that bring about fermentation are using the chemical reaction to produce energy, which they need for their living processes. The reactions that are useful in fermentation biotechnology are mostly